Okay, so now you've watched a little bit of an introduction to complex numbers. I'll just walk you through a couple little things that might help you. So what we've got is we've got the square root of minus 1 is defined as I. So what that means is that I squared, if we square both sides, must be equal to minus 1. Now we can do a few things with this. For example, we can get an expression for I cubed. Now I cubed is really, that's an equal sign, I squared times I. Now I squared, by definition, that's a square there, sorry. I squared by definition is minus 1, multiplied by I, so that just gives you minus I. So similarly, if we had something like, say, I to the power of 5, we know that's really I squared times I. Now I squared is minus 1, so minus 1 times minus 1 is 1, times I is I. Let's have a look at rewriting some numbers using complex numbers. So for example, if you had the square root of minus 16, it looks a little bit odd, and as you know in the real number system, you don't have a solution to this, but we can split this up into root 16 times minus 1. Now root 16 you know is 4, and the square root of minus 1 by definition is I, so this part here. So we can write that as 4i. Now what that allows us to do is solve equations like this. So if we had x squared plus 2x plus 4 equals 0, let's have a little bit of a think about solving. So using quadratic formula, you'll end up with x equals minus 2 plus minus square root of minus 12 all over 2. So it's this part here that's causing us most concern. But now that we know a little bit about complex numbers, we can write this as minus 12 plus or minus root 12i all over 2. Now a little bit of simplifying, root 12 is 2 root 3, and the 2's will cancel, so you get minus 1 plus or minus root 3i. And that's your solution to that previously unsolvable question. So let's have a look at this. So let's say we've got an equation z cubed equals minus 8. We want to find what solutions satisfy this. So what we can do is we can rearrange it. So you get z cubed plus 8 equals 0, and then we can factorise it. We end up with z plus 2, z squared minus 2z plus 4 equals 0. So you factorise cubics before in your other classes. Now this gives us a couple things to think about. So one of the solutions is going to be z equals minus 2, which makes perfect sense because minus 2 cubed is minus 8. However, we need to solve this part here, and that's very similar to what we've done up here. So if we consider z squared minus 2z plus 4 equals 0, here's a solution to that. So your solution to this part of the quadratic, or this quadratic equation is done here. So z equals 2 plus or minus the square root of b squared minus 4ac all over 2a. We end up with a minus 12 again, so very similar to the one above it. So these are our two solutions for that part. So our three solutions for this equation is z equals minus 2, 1 plus root 3i, and 1 minus root 3i. You can write that in factored form. So if you want to write it in factored form, it's z plus 2, z minus that first one there. So we'll write 1 minus root 3i. And if we go z minus that one there, we get 1 plus root 3i equals 0. That would be that written in factored form if you were asked to do that. Good luck.